Hello. So for this video, I'll talk about ionic bonds. And what's important that before I go into the simple fact of bonds, we need to know what are ions. Okay. So just very briefly, we're going to talk about ions. That was a very bad run of it. And then yeah. So if you pay attention to the periodic table on the far right side, well, you see helium on top. Lower you're going to see let's say neon, argon. These guys are known as noble gases. Alright, and on their valence shell, it's full. They have a full complete shell. And for helium, it's 2, while the others have 8. Okay, and dots everywhere. Good old octet rule. And when you have 8 electrons on your valence shell, they're very unlikely, or no, not very unlikely. They will not react with any other element or any other compound or molecule. Right? They're so stable. They're fine on their own. They're cool. They're like the cool kids in the block. Okay. And then they are going to stay like that. And a lot of elements on the periodic table want to be like them. They want to be like the cool kids on the block. They want to be like, willing to do some drastic stuff to become like that. Okay, so like sodium, chlorine, and hydrogen. The guys on the far left side, which calls alkalines, these guys will have usually one, electron on the valence shell. These guys, Earth alkalides, you have 2 guys. Okay, and to become like the noble gases, they are willing to give away those electrons. Like, oh, go away! I want to be like the cool kid of the block. A little bit of a sellout in a sense. Yeah, so they ditch their electrons, and they become positive. Let's use another ink. Okay. In this case, we've got positive, Cl positive, hydrogen positive, calcium. There's 2 of them, so it becomes 2 plus. Okay, and these guys down here are known as cations. Okay, cation. Okay, and they're positively charged. It's very important to see the positive here. Okay, this guy lost 2 of them, so he's twice as charged. Okay, and same thing goes for the other side. Okay, right next to the noble gases, we have the halogens, such as chlorine. We also got bromine there. Yeah, I guess we'll do that. I don't need to go into details. And these guys have 7 electrons on their valence shell, right? And just like the cations, they want to become the cool kids. They want to, but they don't want to lose all 7. It's so much work to lose 7 electrons. So instead of losing 7 electrons, they'll say, you know what? I'll just get one. I'll steal one of cations' electrons because they don't want it. So I'll just say, you know what? I like you. You could come to me, and I'll take one of your electrons. And they'll take those electrons, and they become stable, right? Stable enough to become like the noble gases. And these guys become anions. This is minus because they gain an electron. Electron is a minus thing. So these guys we call anions. Okay. Yeah. Don't forget, I forgot to also I should mention that anions are not exclusively only for elements. They could be also known for compound stuff. Minus. Not a popular one. We all should see is OH minus. These are also known as anions, and they're, as you see, they're not one element. They're actually a molecule. Okay. Now the next part is very simple, because once you know what are anions, then it's a case of understanding that one cation, which is positively charged, is very attracted to the anions with negative charge, and they will create this ionic bond together because there's that charge going on between them, a chemical charge. It's important to know it's a chemical charge, and that's about it. And this creates our ionic bonds. Thank you, and I'll see you next time.